In this video, we will practice using the law of sines or the law of cosines to solve word problems. Problem number 5. Two sensors are spaced 700 feet apart along the approach to a small airport. So we're talking about the approach to a small airport. I'm going to redraw this picture in a second, but here's the basic idea. Here's two sensors. They're spaced 700 feet apart. So this is 700 feet. As we approach a small airport, so we're approaching the airport like this. So a common mistake is students will try to put the plane right here between the two sensors. That doesn't make sense. This plane is traveling at hundreds of miles per hour. This is only a 700-foot space. It's only going to be at this position for like the blink of an eye. That's not what the problem is about. These sensors are 700 feet apart and the plane is approaching the airport. When the aircraft is nearing the airport, the angle of elevation from the first sensor to the aircraft is 20 degrees. So that means the angle of elevation right here is 20 degrees. And then the angle of elevation from the second sensor to the aircraft is 15 degrees. So this angle of elevation here is 15 degrees. Determine how high the aircraft is at this time. So we'll need another line to represent the height of the aircraft. I think I'll do that in teal. Okay, so that will represent the height of the airplane. So this is what we are actually trying to solve, x. This is, of course, a right triangle right here. So here's what I'm thinking. Look at this small right triangle with the x and the 20. If I only knew the hypotenuse, let's say that I knew that the hypotenuse was, let's say 300 feet. I don't know. Let's say that was 300 feet. I could solve this for x using the sine function. Sine of 20 is equal to opposite over hypotenuse, x over 300. So once I find this hypotenuse, I'm home free. I will be able to solve the problem. But I don't know this hypotenuse. But I can use the law of sines to find out the length of this side. First things first, if this angle on the left is 20 degrees, I should be able to very easily find the angle on the other side because we're talking about a straight line. Together they have to form 180 degrees. That tells me that this must be a 160 degree angle right here. Now I should be able to easily find this angle near the airplane because the sum of the angles in a triangle must add up to 180. So all I have to do is subtract those two angles from 180. So I can do 180 minus 160 minus 15. A very small angle indeed, 5 degrees. So this is a teeny tiny 5-degree angle. But there you have it. So now I want to find the length of this side. I'm going to go ahead and call this y. Yeah, I'll just call it y. So if I want to find y, I'm going to use the law of sines like this. Y over the sine of 15, right? That's the angle that's across from y. And that's going to equal 700 over the sine of 5. So I should be able to solve this for y. I am going to simply multiply both sides by the sine of 15. And that's it. these will cancel each other out. Now y is by itself. So let's use the calculator. Let's see. So fraction mode, 700 sine 15 over sine 5. So that is 2078.73. Okay, so that is the value of my hypotenuse right there. So just keep that in mind. This is right here. So as I was suggesting earlier, now I can go ahead and just use a good old-fashioned sine function to find x. So the sine of 20 degrees, sine is opposite over hypotenuse. So that'll be x over y, which is x over 2078.73. All right, just double checking, 2078.73. To get x by itself, I'm simply going to multiply both sides by 2078.73. That way these will cancel each other out, and this should be the answer. This is the height of the aircraft at the time. All right, so here comes the final answer. Okay, so I'm gonna do 2078.73 times the sine of 20. I'm getting 710.97. And because this is a word problem, let's be extra careful to use our units. The lengths were in feet, so this height will be in feet. So that's the answer to problem number 5.